Hello all, this is Nagendra here, presenting you task number 6 as Data Science and Business Analytics intern at the Sparks Foundation. Here the task is to create decision tree classifier and visualize it graphically. Let us go ahead. Here these are the libraries that I am importing for this task. Now, in order to get the dataset, we are importing it from the library called Datasets. Let us have the look at how the dataset look like. So the dataset has 5 different kinds of features, out of which 4 are the independent features and fifth one is the target variable, that is species type. So this dataset has 150 rows and 5 columns, and these are the columns: sepal length in centimeters, sepal width in centimeters, petal length, petal width, and the species. So if you could see here, there are 3 types of flower sets in total, out of which which are classified equally with equal number of flowers for each type of flower. We have 50 flowers for each type of flowers. Let us see what are those types. And in this data set we have 0 null values. Let us visualize the dimensions of the sepals and petals. So if you could see here, just a second. So in this diagram we can see the sepal dimensions. So these are the these are the sepal dimensions of class 0, and these green one are the sepal dimensions of class 1, and these blue one are the dimensions of class 2. So if you can see here, class 1 dimensions can be linearly separable from class 1 and 2. Class 0 are linearly separable from class 1 and 2. And similarly, if you can see here, the sepal dimensions, the petal dimensions here, it should have been, just a second. Yeah, it is petal dimensions diagram. So in this petal dimensions, class 0 is again linearly separable from class 1 and 2. It ranges from 1 to 2. The petal length of the class 0 ranges from 1 centimeters to 2 centimeters, and the petal width ranges from 0.0 to 0.5. Whereas for class 1 and 2, the petal length ranges from 3 to 5, and the petal width ranges from 1 to 1.5, 1.8, something like that for class 1. And for class 2, the petal length ranges from 5 to 7, petal width from 1.5 to 2.5. So we have visualized the sepal and petal dimensions. Let us also look at the correlation between the features and the target. So this is the correlation table. Here we can see that petal length and petal width are closely correlated, positively correlated, and the sepal width and sepal length are not that much correlated. So now we are splitting the data set for feeding into the algorithm. The train set has the shape 120,5 and the test set has the shape 30,5. So we have splitted the data set, and this is the algorithm we are training to, that is decision tree classifier. So we have we have fed the data train x and train y to the algorithm and fitted with this data. So we have got 0.93 accuracy. Again, for the classification problem, we should not only focus on the accuracy, because if the data set is not balanced data set, the accuracy doesn't evaluate the performance well. So the accuracy of the model doesn't tell anything about the performance of the model in case of the unbalanced data set. So we have to look at other metrics for this classification problem. They are accuracy, that they are confusion matrix, precision, recall, and F1 score, and also ROC AUC curve, and we can also see log loss function. Let us see how the confusion matrix look like. So in confusion matrix, along the x-axis we have the original data, original values of the classes, and along the y-axis we have the predicted values of the classes. So here TP means true positive, FE means false positive, false negative, and true negative. So if you can see the confusion matrix for the predicted values. So here for the test data we have 30 data points, out of which 6 are for class 0 and 14 for class 2, and 10 are for class 6 for class 0, 14 for class 1, 10 for class 2, altogether 30 data points. So out of which 6 data points have been classified as class 0, and 13 data points are classified as class 14 data points have been classified as class 1, although 13 data points are originally correct, and 13 data points are originally belongs to class 1, and 1 data point is originally belongs to class 2, but the model predicted 14 data points belongs to class 1. Similarly, 1 data point is belongs to class 1 and 9 data points belongs to class 2, but the model predicted total 10 data points are belongs to class 2. So in this case we have good precision value and recall value, so this model actually works relatively better. So in this confusion matrix, y-axis represents the predicted values and x-axis represents the original values of the class 0, 1, 2. Okay, now let us have a look at the model. Let us visualize the model, how the model actually performed. So this is the decision tree with which the model actually performed. So this decision tree algorithm actually splits the data into based on some conditions. So here it considers some characters like information gain and decides the root node. Here the petal width has been considered as a root node. So this algorithm applies the condition that if the petal width less than 0.8, it is just a second. So based on this condition, petal width is less than 0.8, it splits the data into two different data sets, and again it splits the data with this condition. Petal width is less than 1.75. So similarly, based on this conditions, the algorithm splits the data, and finally for each leaf node we get the Gini impurity as 0. If we get the Gini impurity as 0, the data set has been classified correctly. We can also use the entropy to actually split the data. So finally we have got all the leaf nodes as Gini impurity is 0. So this is how the decision tree algorithm works. Thank you very much.